Hello everyone and welcome to our Lab in a Bag Out and About Connect series, where we learn more about the science, technology, engineering and math happening in our community. This is part 2 of our Recycling Works plant tour. But first, some definitions that are going to come in handy. So first of all, reduce. This means to cut back on the amount of trash we generate. Reuse means to find new ways to use things that otherwise would have been thrown out. And recycle means to turn something old and useless, like plastic milk jugs, into something new and useful, like playground equipment and recycling bins. I have an observation challenge for you. So what do you see in your recycling bin at home? What types of things are in there? Are they different colours? Are they different shapes or sizes? Which items are heavy? Which items are light? Make some notes in your notebook. You can draw out the shapes and you can get an adult to help you out as well. In this video, we go on a behind the scenes tour with Daniel Zelaya from Recycling Works. Here is a very brief overview of the recycling plant process. The items are passed along a conveyor belt where they are sorted into non-recyclables, corrugated cardboard, paper, plastics and cans. This is done by the help of human hands, machines and artificial intelligence to help sort these items. Once sorted, each type is then bundled together and is sold to a mill to be repurposed into something else. Now let's head over to the beginning of the process with Daniel.
Right here guys, this is for our tipping floor. So at any MRF plant, the tipping floor is exactly what it sounds like. Any inbound truck that comes in, they tip their material into our floor, and this is where the process starts for our separation of material that's coming in. This right here is our metering bin and our metering drum. So that drum is rotating at a specific RPM that is controlled, and that allows for material. When the front loader puts it into the metering bin, it's all clumped together. So the purpose of that metering drum is to create separation in the material, space it out, making it easier for when it enters our pre-sort station and it gets its first interaction with human hands. Notice there's a lot of hoses and there's a lot of non-recyclable material that is stuck around that metering drum. And that is where videos like this and educational purposes really help the community, and it helps us avoid having that type of material in our stream. Even though it doesn't affect our operation, we still have to clean it out at the end of every shift, but that way these are things that we don't really want into our facility.
No garden hoses.
No garden hoses. So this is called the pre-sort line. So in these pre-sort lines, we got 2 team members. We got Danny, we got Luis. So what they're doing is that they're separating the material that is not recyclable. So that they're eliminating any paper bag, any paper film that is in our stream. And also, we know that we get a lot of residents that bag their recyclables. So even though there's a big no-no for us, but when we do get that, their job is to tear them open and obviously take out all the recyclable material that is inside. So after that string is separated, it goes into this piece of equipment. And if you want to go right here, Lara, and you want to we really conform to the elements of the material. If the material is wet, we like to incline it a little bit more up, so that way the lighter material goes up and denser material goes down. If the material is a lot lighter or dry, then we like to angle it a little bit more down, so that way the material floats nicely on the screen. So with a series of stars and rotating shafts. It's rotating at a specific RPM. That's causing the first separation of material. So all the cardboard, all the corrugated and lighter material is being separated first at this stage in time in our plant. They're creating a good separation, so that conveyor belt is getting very good, good clean stream of just corrugated material. So what was once just a large clump of everything, now we have separated the first material, which is cardboard. So we got 2 team members, 2 hand sorters that are taking out any plastic they get through or any type of plastic film or plastic container, and they're throwing it and reintroducing it back into the main pile. So the rest of the material that goes through the OCC screen goes through that system conveyor right there, and then it goes up this conveyor system, and then it goes through the next then it goes through the next pre-sort line, which is where through the involvement of more human hands, and Lara will partake in this section right here. She is going to be hand-picking certain things that we remove at this stage in time in our stream as well. So Lara, in this line, what you're going to be separating, so what Alfonso and Tanya separating are just any pieces of corrugated they get through our system, our OCC screen, and they're throwing it down in this bunker. So Lara is going to demonstrate to you kids exactly how a sorter works throughout the day here at Recycling Works. Over here, I want you to remove any plastic film, any plastic bag you get through like this. So plastic film, or a bag. Yep, like that.
The recycling stream then goes into another OCC screen that separates based on the weight. But what happens when the material is the same weight but a different type, like paper versus plastic? How would you sort it? As you could see from my attempt to sort the recycling, it's quite hard to separate the plastic film from the paper, and they are of similar weight. So there is an artificial intelligent eye that scans the stream to separate paper from plastic.
With the light, that's our green eye. So that is artificial intelligence. It's programmed to read certain fibers. So when paper goes underneath it, we're trying to really separate paper from plastic containers. So that's why you see a good stream of paper on this conveyor belt system. And then robot is cleaning all of the stream of paper, and then it's in the forward. So this is another artificial intelligence robot called an optic guy. So that is programmed This robot is programmed to read PET bottles. So this specific type of plastic. So when it goes underneath the conveyor belt, this robot is sensing programs to prevent all the white stuff in the PET. And with the help of air jets, it's shooting all the material out from the screen, so it's getting separated at this point in time. So you can tell that robot is doing a very good job. So before the addition of this green eye, this optic eye, we had to hand sort all that material, and we were losing efficiency. So right now, we're about 90% efficient with the material that we're capturing. So we're losing about 10%, which is far greater, which is way better than we expected. So all the AI technology is doing their job of making sure everything is being processed a lot more efficient and a lot faster than what human hands can go ahead and do it. So on this conveyor belt, we're still getting a lot of plastic bottles that are not drained, being captured by the optic eye. So we got human sorters here taking out certain types of plastic. So our first sorter, she's separating still the clear plastic that gets through the system. So that's going in that bunker. Our team member Patty, she's separating all that clear, cloudy material, which is called natural. So this is our HDPE natural plastic. So that gets bunkered separately. And then our third team member, Luz, she's separating all the solid colors. So this is referred to as rainbow. So anything that is detergent, any solid color container gets separated separately as well. This giant magnet right here is picking up all the tin. So all the tin is being picked up by this magnet separately. So all your So Leah, so your question that you had about your soup can, this is where it gets separated by this machine right here. So this magnet attracts the polarity of tin, and it just shoots it into that bunker right there, and that's being separated. And then our last stop is at this point, you can tell that the volume of the material is very, very light. So all the material has been processed through the use of all our human sorters, our team members, and then also our AI technology. So all we have left is just aluminum cans to separate. So this piece of equipment that down here is called Eddy's current. And Eddy's current has the magnetic polarity to attract aluminum. So it takes it away from the tree and it takes it down here on it. So down there we're getting a very So this right here is our inventory yard. So this is where all the material that has been bunkered, as you can tell, our team members, our sorters, and then also our AI technology does a great job of making sure that every single product that we get in, whether it's your milk jugs, whether it's your soup cans, aluminum cans, your Amazon boxes, etc., everything gets processed and separated accordingly to what there is and grouped together. So this bale of natural is just waiting to be picked up by a buyer, and then it's gonna go out to a different plastic mill and get repurposed, broken down to its main components, and probably be reintroduced in a plastic container of one form or another. Okay. So we got the rainbow solid colors. We got PET bottles, which is your clear water bottles and soda bottles. We got tin, and then we got a good mix of corrugated. Yeah, so 1 bale of aluminum is about half a ton, so 1,000 pounds. Yep, 1,000 pounds. So plant 1 primarily just has 2 balers. So 1 baler is for straight conveyor belt, is just for straight cardboard, so straight corrugated. So in this plant, we process the equivalent of about 17,000 trees that we probably save on a weekly basis. So the amount of corrugated that we get from, majority of this comes from factories. So a lot of these corrugated comes from like Keystone, which is one of our biggest customers, Lippert as well. So a lot of manufacturing companies have large containers and they throw away pretty much all their disposed of correctly, or their corrugated comes to us in plant 1, and we do anywhere from about 100 tons of material on a weekly basis of just corrugated. So that's about 17,000 trees that we're preventing to be cut down and reused for great virgin pulp paper. So instead of we're saving that amount of trees, so that way all this gets reintroduced back into the market, to the tree. In terms of my career path, I was always interested in recycling. I was always interested in just creating, you know, a solution for a problem that was always ongoing. So I remember in my household, kids, that we would recycle at a young age. I remember seeing my parents recycle, throw away, separate things. But once again, I was always like, where does that go? You know, since we're doing all this, where does it end up in? Are we using the same material that we're recycling? Like, and does it re-enter the market again? And that's something that definitely sparked my interest. So I definitely went to college. I got my degree in business and accounting, and even though it really didn't have nothing to do with sustainability or anything in that point in time, it really did prep me for, hey, you know, I wanna just learn more, you know. So definitely, kids, go out there, educate yourselves, read, familiar yourself with material that is associated with a career path that you guys definitely want to pursue, and just follow your passion. Follow your passion, and I think that's the best advice that I received growing up, and that's the advice that I want to take over to the kids at Ethos is, you know, follow your passion and just pursue it, and just study hard and go for it, kids.
We have an additional question from Oliver. He wants to know how items are made into new things, or like maybe what happens after it's been bundled. Where does it go to from here?
Oh, Oliver, thank you so much for your question. That is a great question, and that's actually a very, very, very important question for our facility, because after all the material that we get separated and we're able to process it, and all the materials grouped together that's similar, where does it go from there? And that's a very good question. So that's where the business and sales aspect of our business comes into play. And we have brokers, which are just individuals that have contacts with mills. So there's paper mills that we send our cardboard to, our paper products. There's also mills that deal with plastics and tin and aluminum. So whenever a material gets baled and sold from our facility, it gets picked up by a semi-truck and it goes out, Oliver, to a mill. That mill, whether it's a plastic mill, whether it is an aluminum mill or a paper mill, they just break it down to its properties, to its original properties, and then that material gets remade into a new product. So for example, an aluminum can that goes through our system, when it gets to its end user, in 60-day turnaround, it's reintroduced back into the market again as a new soda pop can.
Wow.
Yep.
Awesome. Well, I hope that's answered a couple of your questions there, Leah and Oliver. And if you have any more, please feel free to send them through to us, and we'll try and make sure you can get them answered as well.
Thank you, Daniel, for taking us behind the scenes of the recycling plant right here in our community. And a huge shout out to our wonderful sponsors for making Lab in a Bag possible. Barletta Boats, Gasket Tape Inc., the Rex and Alice A. Martin Foundation, Heimco, Welch Packaging, and Beacon Health System.